Hello everyone, today we will see the working of hydraulic jacks. Now these hydraulic jacks are used for tightening of most of the nuts in main engine, auxiliary engine and other parts. So normally in main engine it's 1500 bar is the pressure, opening pressure of most of the hydraulic nuts, and the same as auxiliary engine also around 1000, 1500, 1600 bar. So we will see how this works and how we'll see today how hydraulic jacks works. This is taken it from the manual. This is actually a diagram of a hydraulic jack. This is a hydraulic jack. I will give a brief introduction of all these parts. Now this is known as support, and this is a Tommy bar, and this is an O-ring, and this is a backup ring. Normally O-ring is rubber and backup rings are Teflon. So O-ring with backup ring. O-ring with backup ring. Now this is what focus. This is actually the cross-sectional view of a hydraulic jack. You will see there are two parts. One is this. There are two parts. One is this one, and one is this one. Now we draw this like this. Comes here, goes here, comes here. This is one part, and this is another part. It comes here, goes here, goes here, goes here, goes here, goes here. This is other part. I will take another pen. The color blue. Let's do it blue. Okay. This is one. This is another one. This goes here, goes here, goes here, goes here, goes here, goes here. Look. These are two parts. Now we have here one O-ring and backup ring here, another O-ring and backup ring here. So two O-rings and backup rings. Now this is the coupling, to which there will be a hydraulic pump, which sometimes use compressor air to pump, or sometimes by your hand. So this coupling, from the pump there will be a hose, and hose will be connected to this coupler. So from this coupler, oil comes inside to this, and inside to this space. Take another okay, to this space, yellow space, to this space. Now we'll see this is a small external nut. While once we connected we pump, we need to remove this purge to avoid any air inside the hydraulic jacks. Now why? Because air is compressible, and this liquid oil which we are using to for the operation, which is not compressible. So for the operation do it perfectly, we don't need any air inside. We have to remove all the air inside, and also from the hose, also from inside the space, this yellow space. So that's why we need to purge it. After purge it, if there is no air bubble, you have to fix this back. Now let's see how this works. Okay, let's now see how this hydraulic jacks works. Now let's see, this is a bolt. Now this is threaded up. This is threaded, and let's see, this is the length L. Now what we do is we elongate this bolt. By using hydraulic jack, we elongate this to L dash. Now see, these are the two parts. Now this is one part and this is another part which we need to tight. First we put a nut, thread a nut inside, and until by hand touch here. This is a nut. Nut. These are the parts. These are the parts which we need to tight. This is a nut. First we tight nut until it touches this body part and this head of the bolt touches here. Now we need to tight this hydraulically. So what we do? We put a hydraulic jack. Hydraulic jacks normally, as we said earlier, has two parts. The one is bottom one is like this. Another is top one. I will draw only one part, one side. Another is like this. Very simple. Like this. These are the two parts. This is a simple diagram. It have two O-rings here and here, and it does have a coupling which gives oil to these parts. This is a coupling, and the other side, as we said, okay, I will draw here also. Okay, like this. No. Okay, now it will have a small plug here also. So once we fill oil here, oil fills here all around, then oil comes out here, and we plug this with a external plug. We put this, there is a coupler. The coupler will goes to a pump. The pump may be sometimes air pump, main engine, and hand pump in Hawker engine. Now it fills oil. Once it starts fills oil and it is filled, this part will move down. Normally we tight it fully until it touches here. Both part touches here. Then we lose it. Normally for tightening, quarter turn. Actually we don't even need a quarter turn. I will tell you why after end. Normally we lose it at quarter turn. That quarter turn is good enough. That quarter turn is good. Now fill, then because of the quarter turn it slightly lifts up. First it touches here, this part, then it slightly, because of the quarter turn, it slightly lifts up. Now we give oil. This part goes down and touches here. Once it touches here, and again we increase the pressure. Until it touches here, it will not increase the pressure. After it touches here, it starts increasing the pressure. What starts increasing the pressure? Increasing the pressure means this part will move up. Now how this stud is elongated? This stud is elongated by a force, F. This force, how we get this force? This force is got by this pressure. This pressure is not this all around the jack. All around the jack there is an area between the two O-rings. One O-ring, two O-ring, two O-rings, one O-ring, two O-ring, two O-rings. There is an area. In this area there is the pressure is acting. So depends upon the area is the force. So for I've told you, because in main engine it's 1500 bar for almost all jacks. Now you may thinking the stud size are different, then how it will elongate? This is how the pressure is what the force. The pressure on the area is what the force. F is proportional to P and A. Now pressure is constant, so the area of the jack for main bearing and all the bigger jack, so area of the jack is bigger, so more force, so it will elongate. So for piston palm molds, the area is smaller, so the stud is smaller, so the area of the jack is also smaller. So it will start elongate, and 1500 reaches the pressure in the pump, 1500 bar. Then there is a pressure which we need to hydraulically tight this. Then there are, because of 1500 bar, there is a certain force which is acting up on here. That force will keep for an elongation of L dash. That is a force which gives you an elongation from L to L dash. And then we start tightening this nut. This is the nut, and we start tightening this nut until this nut touches the top of here. Now once the nut touches the top of this part, then we release the pressure. Once we release the pressure, what happens? This will not goes back to L dash to L. It will not goes back to L dash to L. So to keep this in L dash, we require a pressure, right? Because in L there is no tension, no compression on the bolt. So in L dash there is tension on the bolt. So how to keep it in a tension within an elastic yield limit? There need to be force. And where is the force? Because we have removed the pressure. The force is on the nut. Between the nut and the thread of the stud, there is the force. The force, it is the nut which keeps the stud elongated. So once we relieve, this stud is not gonna compress by 12. So here this gap will be same, and this gap will be equal to the elongation of the stud. So what we do, there is, you may be remembering there are small holes on top of here. With the Tommy bar we tight this, then the oil inside this skews up back to the pump. So this will goes down. First we tight it fully, removing complete oil up, then we lose it, then we take out. That is why I told, even if you didn't at the first time, when you didn't turn back 1/4, there is no issue, because you can open this hydraulic jack easily. And also there may not be an issue even if you didn't turn 1/4. But as per the manual, it is clearly told, some manual I have seen, it's told that to turn 1/4, then you have to maybe some design is like that, there is no space here. This upper part and lower part is completely touched, so this pressure may not be acting on here, then it will not elongate. So to give some space to oil to come back in those two spaces, they always ask to lose 1/4. But in some jacks it will never tell, because as per the design itself there are enough space in between. So that is the way we should tight a hydraulic jack. Now let's see how to open a hydraulic jack. Okay, now let's see it in the same way. This is a nut, and these are the two parts which is already tightened by the nut, as we said earlier. And this is the nut. Okay, this is the hydraulic jack. hydraulic jack. Now two o-rings. Here, as we said earlier, this is already elongated to L dash. Now, okay, this is elongated to L dash. Now we keep oil here with the pump. Now first we fix this. Now before that we have to tighten it completely. Then we have to open it 1.5 turn as per the manual. Some manual says different, but you have to check the manual how much turn you need to open. Now I will tell you why we need to open this 1.5 turn. Why is it compulsory and what is the theory behind it, I will tell you afterwards. Now you open, and after that you pump oil in between these o-rings by using the pump. Now you start seeing this gap because we tighten it first, then we lose it. Because of the losing 1.5 turn, this top part which is threaded to the stud which goes up because of losing 1.5 turn. So obviously the bottom part also which is touching at the beginning, which also goes up. When we give oil, then this bottom part goes down and touches here, so the gap appears. That is the gap. Now again we pressurize. We all know that this stud is already elongated to L dash. So we pressurize. So that means there is already a force acting by the nut onto the stud is F, which is equal to the pressure of 1500 bar on this jack, on this particular jack. So when we add pressure, first it will this gap will appear, and it will then when we increase the pressure, nothing will happen. Increase the pressure till 1500 bar, this gap will be same because it's already elongated, and we need to give more force. This force is there, like F is the force, then which is equal to 1500 into area of the jack, area of the oil acting on this particular jack. So till 1500 bar we increase the pressure, nothing will happen. Then then we increase till 1500. We have to increase it slightly more, 1505 or 1510. Then this pressure might be different, it's not the same for everything. So slightly more. Then what happens, this slightly elongates very little. L dash will slightly elongate to L double dash. So this nut also slightly lifts up because this full stud elongates slightly, so the nut is also slightly lifted. So with the dummy bar we can loosen this nut. We loosen 3, 4 or 5 turns of this nut, then we depressurize. First normally depressurize slightly to 1000, then check whether this nut is touching this body or not, because sometimes because of depressurizing this goes down, and with this goes down to L dash to L, so this nut also goes down, so it may touch here, and if it touches here, then we may not able to remove this nut. So we need to check that. So we slightly we need to lose, so that at the end when the pressure is 0, that time also this nut should touches on the top. So we need to loosen it more. Then we slightly reduce it to 0. At 0 you check whether this nut is loosened before removing all this jack, because once we remove, then again we have to put it back, because the whole purpose is to remove the nut. then this will goes down as I told you. When the at the time when it's 1500 bar, this gap will be almost same. When we reduce this after removing this nut, this hydraulic jack is the one which taking the elongation force completely. When you remove this pressure when we depressurize it, it is going back from L to L dash, because there is no nut or nothing which takes up this force F. So what happens? This gap started reducing. Gap started reducing until it's zero, so that this gap started reducing, and this gap started reducing. So when at zero, there should be some gap in between the upper part and lower part of the jack. Otherwise, what happens? This upper part will touch the lower part, and the whole jack will get tightened like the nut. So we'll may not be able to open this jack. So to open this jack, we are actually opening the jack at the beginning. I'm told we have to rotate the jack anti-clockwise to maintain this gap, so that at the end uh, this hydraulic jack should also be free when the elongation when the length of the stud is L reduced to L dash to L. So that is the whole theory behind it.